Hello, this is Luke Hatfield. I'm the person behind L3D Help Guide on YouTube, well known around the Creality groups for tuning and assembly help guides, stuff like that. This is going to be me helping out a friend Matt with assembling 3 Ender 5 Pros. They're going to get some printed upgrades, they're going to get some purchase upgrades, extruders and the like. I don't have a formal plan for this, so it might seem a little varied as I go through the process or whatever. But the first thing is I'm probably just going to assemble all 3 of them, and then we'll go about doing the mods one at a time. And I'll probably pick one to be the lead one. That way, if I run into anything I wasn't prepared for, I can sort of not mess it up on all 3 at once. So that's how I'll go. I don't expect any problems. But anyhow, welcome aboard. It's going to be a little quiet in the background. I really don't want a copyright strike for music or other things playing in the background. Usually in my shop I have either YouTube videos playing or music playing, but it's going to be pretty quiet. The only thing you're going to hear is the CR10S Pro that's currently running in the background, making some ear savers for a friend of mine here locally. So anyhow, welcome. I'm going to have a brief break as I sort of post the streaming link up in the official group and get started here. So I'm going to step away from the camera. My apologies, but I'm a one-man show. My son, who's usually my cameraman, is having to be outside of the home for a little bit. He went out with family, but my other son is in chemo treatment, so he's having to isolate from the family before he comes back in, so we don't accidentally give my son in chemo a cold or something that could be catastrophic, as he's still got one more round of chemo left. So anyhow, enough about that. We're going to get started here in a minute, and there's not going to be anything special. I will talk about what I'm doing as I'm doing it. Later on, if I can get my my guy that does my video editing to go back through, I'll probably try and timestamp specific things if we can. If not, then it's just going to be a video of me doing this that takes a long time and isn't really set up to take anybody from beginning to end unless they got a lot of time on their hands. But I thought it might be fun. People can see some of the tools and tips and tricks that I do as I do an assembly firsthand. I've got most of my stuff laid out just out of sight here on the table where you can't see it, but I have enough stuff here to almost build a printer from scratch other than the extrusions. But anyhow, I'll sort of show you what I do, how I label things that I like to do to the printers, all of it, as I go the process of making these printers ready for mass use. So I'm going to get that announcement up and then we'll get started. All right. So the bouncing around in the background is me harvesting ear savers off of the CR10S Pro and restarting it. And now you'll hear the steady thrum of my CR10S Pro working in the background. Okay, so here we go. I'd already cut open the top of this one. As everybody knows, they come with an assembly guide. It's actually pretty decent. Edutech does a even better advanced video showing some of my alignment techniques or whatever, but you can get there with the regular guide. But there's things that we can do better than what comes in the factory guide. Some of the stuff I'm going to set down beside me until I need it. If you guys haven't received printers before, always check the box for loose screws that got kicked loose and knocked around or whatever. Set that down for the minute. And Matt, I'm pretty sure you're watching, or you'll at least be caught up here in a minute. So I'm going to check the frame really quick to make sure that a little bit of damage on the cardboard box didn't affect any of the internals, but I don't see anything that's giving me any alarm to the printer being messed up. So most likely, if anything got damaged, it would have been making this frame out of squares. So we're going to sort of do a cross corner check to see how square it is. That's 22 and just under 13/16. Get my eyes checked. 21 and 13/16. Right. So it is a little bit out of square, but I think I should be able to get it racked out properly. Oh, what are we looking at here? It's maybe easier to work on the squaring stuff for visuals upside down. And that intersection there. No, it's not out of square. We're fine. I was measuring from the wrong spot to the wrong spot. It's square within a 32nd of an inch. All right. That's good news because I didn't want to have to mess with it anyway, so it looks pretty square. All right. So we can move on. Grab the hardware out of this box. And that stuff right now. Those. Grab our base unit. First thing you always want to do is make sure your voltage selector is right for your country. 115 is what we're using here in the US. Okay, so I need the screws over here. Oh, and not that it's a huge thing or whatever, but even on the top of the lid of the control box, or the PSU box, whatever you want to call it, there is actual other instructions to help with the assembly of these things. The biggest things we're going to do is I'm not going to over tighten anything as I get it fully assembled. I will check it for square in a couple directions and then just slowly tighten everything a little bit at a time so that I don't knock anything out of adjustment. And so for those who've never assembled one before, there's machine threaded hole on one end and not the other. The threaded end goes into some brackets on the upper XY assembly. So you just want that end up away from the other end. Put them on one at a time. My apologies for not having music playing in the background, but I don't have any music set up that's free reshare music or whatever. I didn't think that far in advance. I'd really hate to get a strike on my channel just because I was lazy about my music selection. If you didn't pick up on it, almost any printer, when you go to assemble it, even the big high gantry machines, you can just sort of get one edge of the printer over the edge of the table. It makes assembly way easier than trying to lay the printer on its side while you're working on it. Okay, we have the lower and upper together. Then we need to put the top onto the bottom. So this box always goes towards the front. The Y stepper motor is always in the back. Pretty easy to keep track of. I'll just set it up on top of there to get things started here. Hey Gary T, how you doing? Silly string on there. Okay, so there is secondary screws or bolts that go on from the top to help empty that. Let's see if I can put those in there. Are those shorter ones? I don't remember. I'm gonna try those in the hardware pack. No, it's not those. So if you guys didn't figure out what I was doing, that bracket just looked a little cattywampus or whatever. It does have a long slot in it that allows for belt adjustment and whatever, but I just wanted it to sit more straight before I put the screw in. And as you saw, the amount of belt tension I got was just what I could get with a couple fingers pulling on it. A lot of people over tighten the belts to the point where they're almost stretching the belts, ruining their dimensional accuracy and causing other problems. And Derek Cirillo, this is flashbacks for him. His first printer was an Ender 5 Pro. That's a good one to start with if you're going to have the first printer to start with. My first printer was an ANET A8 that I got off the marketplace that somebody had done some modding to or whatever. And oh man, was that an experience and a half. And I do have my sort of compound square out here to sort of check things as I put it together. These things generally square up really well, just naturally. And I really don't expect to be doing any quote unquote adjustments to the frame. But we will use the speed square. We can put it up in the corners. We can check to make sure everything looks like it's generally nice and square in all directions that we can check. Yep, that'd be good. Anyhow, we got the top to the bottom. And I'm actually going to start tightening the top, then the bottom, and then we also have to mount the Z gantry up here, or Z axis, here in a minute. So let's get this part put together first, and then we'll do that. You got to tighten these things. You want them firm, but you don't have to like try and strip out the aluminum threads when you're tightening them. In the end, you're trying to control the force of a melted plastic being pushed into itself. There's not a whole lot of force involved at that big point. So we're not building a CNC machine here. There's a lot of people lose track of that. Looks good there. Looks good there. All good on the western front. Tighten you up a little bit. So, how does that look? Looking good now. Good now. When it looks a little bit out of square, you can sort of nudge the frame a little bit to help it square itself up. It'll generally sort of settle in anyway. Get it close as we can naturally before we tighten bolts. There we go. Yeah, so the CR6 SE, I haven't got my, Ben hasn't told me which of the new printers that are coming out that I'm getting. The CR6 SE may be one of them. We'll see. I don't have everything in their lineup, but I have enough of the right models to understand how they work. And the SC has some new stuff on it, so I would imagine I'll end up with one just so that I can support it with my help guide and with the sort of the advanced tuning tricks that I give people. Time will tell on that one. All right. Tighten that one. Yep. All right. And half the time, once you get past the first two corners, everything else is already fallen in line because the cube wants to square itself, which is the case here. Hey, I don't know who's on the Creality account. It's either Ben or Ben or somebody, but hello Creality, welcome. Those three printers I was telling Ben about the other day are getting assembled starting tonight. Let's see how it goes. I don't expect to be done tonight, but we'll get them at least put together and started down the process today. Need to have them ready for Sunday, but I have a 4-day work week this week, so I have all day Friday, all day Saturday. I need it. Let's see how it goes. Okay. So this might seem a little production factory, but I'm probably going to get this frame assembled. I'll show you guys how I square the upper gantry to the frame, and then I'll bust open the next one and start assembling it back again. Just to keep things moving smooth, and I'm not going back and forth between tools and parts of the process and everything. Yeah. So Creality, let me know if that's Ben or Fen. If you want to jump in just to talk in the background or whatever, I've got StreamYard up. All I need you to do is let me know, and I'll send you a link, and we can add you to the stream if you'd like to come in and participate for a little bit. I'll be watching the YouTube feed where I believe this is where you made your comment. So just let me know. And also, Matt, if you want to hop in just to talk to me while I'm putting stuff together, I don't want to leave you out of the process of doing your own machine. So if you have a video camera on your laptop or phone or something and you want to join me on StreamYard, you're more than welcome to hop in here. I have the ability to, I think, to have a couple of guests inside. One of the first things we're going to do is give this PTFE a chance to relax. I am not a fan of tying the PTFE to the wires. Later on, we'll get into how I route the wires, but the PTFE always gets sort of a memory from being in its shipping position or whatever. I like to give it a chance to relax. I can sort of massage it back into a new shape, but it takes a little time for it to take its new shape. Whatever you do, you don't want to put any sharp ends into it, because even with the quality Capricorn, you can introduce problems to it. There we go. Later on, so it's already printed, but these are going to get, we can have a little bit of fun with that. These are going to get a support arm that go on there to hold all the wires where they belong, like that. Already printed those. I'll probably take it off for the rest of this assembly, but anyhow, that'll hold this wire up above, and then this will be allowed to come back to the extruder without being tied into the main wiring harness. Okay, so let us see how well this is writing square to the frame. It's been a while since I did this, so even though I wrote the proverbial book on it or whatever, be patient with me as I remember what I did, because I don't have my own guide up. So there's that. And I need a pair of calipers, I think. Nope, I'm going to cheat a little bit. I'll be right back. I'm going to grab something that makes this easier for me. Not everybody will have these in their toolkit, but these are self-adjusting channel locks from the days gone by or whatever, but I can use those to sort of hold this in place so it doesn't move around as I'm trying to do the measurements of that gantry. So I'm going to hold this square to the side frame, put those on there to make sure that it doesn't move, and I can get a better measurement on how square this XY gantry is. So that's not going to work. Figure out which way we're going to measure this thing. Figure it out. All right, so 99.7. Yeah, so this is, just so you know, Matt, that's within less than 0.2 millimeters in alignment already. So I'm not going to adjust this assembly because it's already squared to the main frame. You don't have to be quite as accurate as I'm being, but Matt's asked me to do these for a precision setup because he's going to be running a print farm. The better we can get it, the better things go for him down the road. So, yeah, so without any fiddling, probably actually less than 0.2 millimeters, but I think I can comfortably say it's less than 2.2. Might even be like 0.15 or less, but you know, it's perfectly square to the main frame. So now I can put on the Z assembly in your kit. This is the longer screws that go all the way through the extrusion into the main frame. They're in a separate baggie. They're the 30 millimeter long ones. If you want to make things more complicated, do it while you're filming a live stream. And on these particular ones, it's not necessarily a weakness, but because they're through the web of the extrusion with their the threaded parts, you want to get them snug, but don't lean into it or whatever, because there is a possibility to strip it, which is recoverable because you can do a through bolt and whatever, but I don't like to have things like that messing with me. And here in a minute, we'll actually probably do the what I call the Z-axis alignment. We'll align the one rod to the corner frame, and then I'll show you how to make both rods be in alignment to each other so that there's no binding in the linear bearings or anything as you're doing your Z movements. There's a new chapter being added to my help guide that's about that, aligning the first rod to the frame. I didn't put it in my first edition of the work for the Ender 5 series. I wasn't ready to share that yet. Anyhow. Okay, so that's attached now. So what I'm probably going to do next is I'm going to take a steel rule, I'm going to put it here, and I'm going to measure across to this position of this Z-rod. I'm going to measure it top and bottom, figure out which is longer or shorter, or if they're parallel. They might already be parallel, I don't know. But we're going to make sure that this rod is parallel to the frame. And then once we've done that, I'm going to loosen this and show you a procedure to align the two halves to each other. So where is my ruler at? It's probably underneath of the laptop. There it is. All right. Anyhow, so sit down again for that. You guys don't want to see my little baby pot belly anyways. So you're going to use the depth. Man, the background here sucks for showing stuff. You use the depth caliper part of my digital calipers, and I'm going to use the steel roll across the frame as a reference surface so I can measure to the rod. So I'm 119.85 up there. With a lot of this measurement stuff, make sure you're set up nice and comfortable where you can really be accurate with the placement of your tools and stuff. Okay. So I'm 118.83. 118.83 and 119.11. So let's do a little bit of math here. I'm cheat and do it on my calculator because with the streaming, I'm not really thinking straight. 19.11 minus 18 point, what was it? $118.83. Okay, so we're 0.3 millimeters difference from top to bottom. So I'd have to do the angular error calculations or whatever, but on your average print, you're not even going to see the difference. But because we're going for ultimate precision, we're going to adjust it now. So the way that we're going to adjust it is there's a pillow block here and a pillow block down here. And I'm going to loosen one and then adjust. Well, I'll loosen this one a little bit, totally loosen the other one, adjust it to the size, get it settled in, then I'll remeasure it. And then, even though 0.28 is not very much or whatever, we're probably shooting for less than 0.08 if I can measure it that accurately from top to bottom. Would be a good goal. So, I'll find the right Allen key. This. So the upper one is my one that's not going to move as much. So I'm just going to loosen it up so that I don't bend the rod as I slide the other one around. So I'm basically just loosening it a little bit. But the other one we're going to loosen up a lot, and then we're going to do our mechanical adjustment. Double check our dimensions, tighten it up, check it again. The stuff is really boring, but That's what you got to do if you really want to precision assembly. Okay, so that's loose enough that I'm not going to bend this rod if I pull on the bottom back and forth. And I'm probably actually going to loosen all of the other side, just because I don't want to pull stress across the frame of that whole thing while I'm doing it. And this is part of what people don't see when I'm writing my guides, is I do things several times before I myself to make sure I don't leave anything out of what I've done, so that when you go to use it, it's a refined process and you know what's going on. Trying to figure out what people do wrong before they do it. Let's type. Those are loose. That one's loose. And I've got an exercise coming up where I'm going to run this assembly up and down a lot. So you don't have to do it if you don't want to, but I am going to undo the Z coupler and take the Z rod out so that I can make that happen fast instead of having to manually screw it up and down a half dozen times as I'm doing my work. So I'm going to undo that screw, or the grub screw. I guess it's technically not a grub screw because the clamp fits on the outside, but loosen that. Take the Z screw out. This is also a chance to add some lubricant to those bearings. They're linear bearings. They do have a decent lubricant from the factory, but we like to use the PTFE lubricant. Oh yeah, I forgot I got my gun on. Yeah, that's a Colt Combat Commander that I wear all the time when I'm not at work. Can't wear it at work. I'm a federal contractor. They put the kibosh on that. But any other time that you run into me in the non-work world or whatever, I will have a firearm of some sort available. All right, so I put some of that PTFE lubricant on. I'll run this up a couple of times just to sort of lube it in there. And it's actually making more noise than it would normally. You'll never move this fast, and I brought a bunch of screws loose, so it's probably going to turn this thing into an echo changer, so don't go freaking out that the machine's going to be super loud because of this. But this is just an easy way to work that lubricant into the bearing. Okay, now that we've done that, we are going to do our adjustment of the position of this bar. Now that the other side is loose, I'm not going to mess it up when I do it. I am going to have to come up with a way to hold this up while I measure the lower part. So we may co-opt this thing as a support. There we go. Improvise, right? As a Marine, it's just one of those things we do. Okay, so let's see if the top is still where it was when I measured it the first time. One 18.8, so it did move a little bit when I loosened it. And what do we down here? Okay, I'm 118.8 up there, and I'm 118.8 2 here. So evidently just in loosening it, it sort of self-corrected. You gotta love it when things do that for you. So I'm going to, as carefully as I can, snug that back up a little bit and recheck the measurements. But that's less than 0.1 top to bottom. And if we can keep it there as we tighten it, I'm going to be happy with that. Okay, so we got one tight top, one tight bottom. We'll check it again. Okay, good. I didn't end the stream. I bounced my mouse. I'm like, I didn't shut the screen, did I? The stream, did I? Okay, 118.85. Oh, there's no real super comfortable way to do this. The 118.82. I think I was 85 at the bottom, so if I can measure that close, I'm 0.03 different top to bottom. I think we can live with that. Okay, so now that I've done that, I'm going to tighten the other screw on this. Top and bottom. Maybe a little support thingy out of my hands way. Okay, that's tight. So now this is the adjustment process for aligning the second rod to the first rod. So this one's fully locked. This one has both sides loose. So what I'm going to do is I'm going to put this all the way at one extreme of operation. I'm just going to finger tight its little bearing pillow block. Get it close. Because right now this is holding it spread apart the right distance, right? Oh, did I forget to loosen up? Hold on. Now to follow the instructions. Okay, so now that pillow block is loose where it can move within the slack of the holes. So we're going to go down to the bottom. We're going to snug it just a little bit. We're basically just using one side to set the other side parallel to itself. So we do that. Make sure that the upper part's loose. Both sides. Okay. So we're gonna, ready. Thank you. So we're going to bring it up. We'll snug this up. Snug it up a little bit with it being held apart up here the same way. I usually just do this twice. So now I'm going to go down below Now loosen its two up just a little bit. This is just in case you're really racked bad or whatever. You go down, tighten it one more time. This time I'm going to tighten it tighter. I'm going to loosen the upper one more time. Tighten it for its final time. So now, not that you'd ever really be able to fully feel it, but those rods are perfectly in line with each other, at least within the tolerance of the bearings. And tighten this up. Tighten the other ones. Okay, so all of them have been fully tightened. We can go ahead and put our Z-rod back on. We'll use this as an opportunity to introduce some of this lubricant to the main Z-rod. Okay, so now one of the things I want to make sure of is that that rod is not hitting the end of the stepper bolt when I tighten that back up. So I'm going to let it go down until it hits, and then I'm going to lift it up like a millimeter just to make sure that the rods aren't hitting end to end. All right. Okay, so that Z-rod is on. We already shipped this with the brass drive nut on this is fully tightened on all 4 screws. I personally prefer to have this loose about half a turn just in case there's any angular problems between the machining of the brass and the drive rod. So what we'll do is we'll loosen those little nuts up, and then I'll put a jam nut on there so that they don't fall to the ground at some point and cause problems for us later. So we are going to add 4 little M3 nuts to this program. There's our nuts. You can also do this with nylock nuts. I do have some of those available, but I'm really not feeling like playing around with them at the moment. Next, smaller Allen key. Part of the build is always dropping Allen keys. If you haven't dropped your Allen keys, you're not doing it right. Okay. This is your dexterity test, putting those little 3mm nuts on. One more. All right. If everything goes well, I can use the hex key up here and the pliers down here to jam the two nuts together. This is one, if you're not really mechanically inclined, get the nylon nuts. They're just easier to work with. Or don't do it. You don't have to do it. So it doesn't seem like much, but that little bit of slop in there will let it work well. Okay, then I guess we can put our bed assembly into place now. We are going to be taking these magnetic sheets off and putting on new TH3D Easy Flex smooth mats. And then I got to remember, does this go on top or bottom? It goes on. See which way gets you the most travel. I always forget. Let's go look at one that I've already assembled because my brain is not functioning right now. All right, for better or worse, mine are assembled with this plate being on top of that plate. If at some point somebody wants to change that, they can go the other way, and then it'll be on the other side of the plate. You're only talking about 4 millimeters difference, and I'm not too worried about it. So I need the pack of screws from the kit that had the little tiny bolts in them. Well, I'm sitting here looking at the same comments thinking nobody's commenting that it's not auto-scrolling. That's nice. Do you ever use the split sprung Z fitting for slot? Oh, you're talking about the anti-backlash nuts. I don't care for those. They tend to trap errors, especially on the dual Z machines or whatever, but everything's running right. You don't really want an anti-backlash nut on there. So answer would be no, I don't generally use the anti-backlash nuts. Not a fan. I understand their use from my machining days. Getting rid of backlash was a preferable thing. In this particular case, or actually in all of the 3D printing space case, there's enough gravity weight holding the machines, and we're only, once we start printing, traveling in one direction unless you do Z-hop. And so it doesn't need to have that backlash regulated so tightly. And even if you're doing Z-hop, doing what I'm doing right now will not cause you problems with moving up and down. So there's that. So that's my 2 bits on those. We'll see if it comes into play later, but I gotta take those bed mats off. I may regret having put these on at this point, but I think we'll be all right. All right, so got a couple extras of those. Put them away. Figure out which Allen key that is. Should you buy the Core XY conversion for the Ender 3 or get an Ender 5? So I've had in the background some non-creality Core XYs, and they can let you go a little bit faster than these Cartesian cubes, but for all the headaches it takes of balancing the belt tension. So what nobody tells you in the dirty little details of Core XY is if you have the belt tension from this side of the drive to that side of the drive out of balance, it will actually make your circles oblong. And well, I'm pretty good at tuning and I can get around that, I don't want to have to. And also, some of them are not putting really quality components at the pivot points. So as your bearings wear, your belt tensions can change and introduce artifacts that you don't want. And honestly, I just don't see the need for speed there. You're 90% of the time, I sort of follow with Tom Sandelar about this. If you want more capacity, add more printers. Go at a speed that works for the printer the way it's designed. And I don't know. Probably because I'm spoiled, I have multiple printers. I just don't have that need for speed. Anyhow, so we got that on. We're at the point now where we could start hooking up some of the electrical. But do we want to do that, or do we want to go back to building the next frame again? Oh boy. You know what, let's just do all the electrical at one point when we go to doing it, because I don't want to be redoing stuff later because I forgot about something coming up in the upgrade process. So that is 1 of 3 together, and the kinematics adjusted. So we did the Y gantry assembly, we did the XY truing. The only thing I didn't really do was I loosened one belt but not the other, so I'm going to see if the belt tensions are about the same. They feel the same, so I'm not even going to mess with that. So this one is good to go. So we're going to open up another one. Okay. Keep that handy, but it doesn't have to be right in my way. That doesn't even need to be in my workspace. All right, so we're starting over again. Yeah, so Raptor rides, yeah, I think we're into 3 alone. If you haven't gone through all of my tuning stuff, I would suggest you do that, because it's a lot like I'm doing here, very precision alignment of parts that make the assemblies work better. But beyond that, there's no big reason to be changing it around. There we go. So we're going to declare the colors on these. He had me do the accessory parts in orange, blue, and black. So just for keeping track of parts and stuff like that, we're going to do, the first one is going to become orange. Second one's going to be blue. And then the third one will be black. That'll help me keep track of the warranty papers and stuff like that. Okay. They don't build 3 printers at a time all the time, so there's going to be a little improvising as we go here. You'll see on the replay that somebody times how long it takes to do the frame build. Did them live for a little over an hour, so it was about an hour to put a frame together and do all of my alignment exercises. Don't judge your progress on how fast I do it. I do this a lot, so if it takes you longer, don't feel like it was a problem. Yeah, so yeah, you can get away without doing flow calibration, E-steps and flow calibration, but like Jeremy's saying, you won't know what you're missing until you get there, right? So it doesn't take a whole lot of time. Honestly, most of the stock machines, if it has the plastic extruder, it comes at 93 E-steps, it'll be 95, 98% of the time, unless you get a mismanufactured hog or something. And whatnot, but beyond that, the flow calibration is where it's at, because you could have a mismanufactured nozzle causing different flow properties or whatever, and that gives you the opportunity to correct for that. Also, if you haven't done my hot and fix, I highly suggest you look into that, because that tightly controls the pressure between the PTFE and the nozzle. It actually creates a compressive force there, just a little bit, that will make it so you don't get that slight under extrusion that Creality is infamous for. But you know, but not everybody's making dimensional parts, right? If you're making models and it just has to look pretty, there's no reason to get too tore up about your calibration. I tend to make practical prints around the houses and stuff, and I want everything, if I tell it to be 4.3 millimeters, I want it to be exactly 4.3 millimeters, so I don't have to mess with it later. And I only have the thing here to look at, but I haven't seen anybody that wanted to join the stream, so I'm just going to stick with what we got for the moment. Yeah, so that putting it in with the 2 turns loose and tightening it, that helps. But what you'll find over time is the teeth in the Bowden coupler will dig into your PTFE over time, and it will actually allow a void to form there. And I've done it with extreme amounts of added compression that way to test, and still over time the PTFE wallers out and you get a micro void. I have a couple of detractors of it. There are people that say, "Oh, you don't have to do it." Um, no, you don't ever have to do anything. But I have an animated video coming up that a guy did for me that illustrates what I'm talking about, and it shows that you will definitely have it happen over time. So there's that. Yes, even with the upgraded pneumatic couplers, the metal teeth dig into the stuff, and you can almost see it yourself when you go to take it apart, because you'll see that, because especially on the Ender 3 that you have, the head's going back and forth, right? So that tubing, if you can imagine my wrench is the tubing. That tubing is getting oscillated back and forth as you move side to side, right? And those teeth are just sitting there cutting in, and then once it gets that little tiny void in there, because of retraction, you're actually, imagine that you're creating a hydraulic chamber with driving the filament in and pulling it back, driving in and pull it out. It creates hydraulic pressure, and they're not a ton, but enough to push against that, and eventually it will drive the plastic up and dig those teeth in more until there's an actual void in between the PTFE and the fitting, where it needs to not be. Where am I at here? Screw. There you go. Yeah, there's plenty of people who run without my hot end fix for years, and they do all right, but they could do better. They just don't know it. Yeah, these things will be getting the hot end fix from the get-go. Right at those bolts around the shop. They were loosely assembled on those. Got one more here. Oh, I see what's going on. I have it in line first. Logo. There we go. And cruise control. I don't think it'll bother you guys too much, but here in a minute I'm probably going to grab that food my wife said was ready, And then I might eat in between steps or whatever to get my dinner worked in here. Oop, that wasn't too smart. Yeah, if you make a mistake like I did and get things out of whack or whatever, don't try and bend things over the screws. You're just going to damage something. Take the couple of seconds, take the screws back out. They weren't tight anyways. I just managed to get that piece because I'd left it so loose on the wrong side of the bracket. Easy enough to fix. Do I order it or print the piece that goes between the tube sections? Oh, it's on Thingiverse. I don't really have the time because I'm in the middle of the stream to do it, but if you look up the original Creality Hot End Fix, it'll pop up on Thingiverse. It's been downloaded over 40,000 times now. Or you can look for my account if you want to know my other designs. I'm L3D_help_guide on Thingiverse. That's my username. I did a rebrand recently. I used to be One Bad Marine, but it didn't really suit what I was doing, so I did a channel change name and got rid of some of my old gun content and rebranded the channel. And here pretty soon, now that I got some better camera equipment to work with, Creality's requested that I do most of my guide and assembly stuff on my own, even though Jim has done a great job with it at Edutech. I'm going to do it again just for another point of reference for the users. I don't mind doing that. They keep me supplied with a pretty fresh supply of new printers to play with, and they take good care of me. Got me out to Earth last year before COVID happened, and they make it worth my while to help users out, which I like to do anyway, so it's a win-win. Okay, got that part going. Still not great that my table is not perfectly square. Well, let's see if it's the frames out or my table's out. I think my table is not flat. That one looks good. So I'll take that. Oh yeah, so you can print it from PLA. Here's the deal. Like a couple people have said, "Oh, I did it, and the little washer melted." Right? So half the time the washer didn't melt. When you use this fix, I'm getting ready to add to my instructions on it. But I make the hole for the PLA coming back about 2 millimeters, which should be more than enough to pull filament back out. But just to get it back out of the machine cleaner, when you go to remove your filament, push to extrude for about 3 seconds, and then swiftly pull back. That way you won't have that bulging ball end on the end of your filament for coming back out, and it won't get caught on the washer. The other reason that people have had a problem with the PLA washer, just print like 4 or 5 of them just in case you have a problem with your heatsink fan. Because if the heatsink fan fails and you have no cooling going on, eventually it'll get hot enough up there to melt the PLA washer. Not the end of the world. You get a new fan, you take one of your spare washers, you take it apart, you put it back together, Bob's your uncle, and you're done. But anyhow, but a couple of people that had heatsink fans fail said, "Oh, if the washer melted." Well, yeah, it's going to melt if your heatsink fan fails. I can't control that, but I've been using it for almost 2 years now with no problems. I've never had a heatsink fan fail to the extent it did that to me. Um, uh, you can actually, if you wanted to do a self-test or whatever, if you put the heat, take your fan off, heat the hot end up to about 200 degrees, put the spacer in there, and if you wait for about 35 minutes or 40 minutes with no heat, it'll finally get hot enough to start softening up the washer. But I assure you that as long as your fan's working, the thing, it'll stay below, like, it won't get up above 40 degrees or so up in that part of the hot end, and you won't have any problems. Okay. You will notice that I changed my order of assembly this time. These three were all made in the same production batch, so I don't have to worry about the first time I assemble, I do it in the order I did to make sure that there aren't any miscuts, like this. The machine that cuts the ends of these was not out of square or something like that. We haven't had that problem in a long time, but some of the early enders had some slight miscuts on them that caused problems. But once I'm sure a production batch is good, they're all going to be good. Okay, so now we start tightening down upward assembly. That is done on the spot. As you saw, if it's a little bit out of whack, you can sort of tweak the frame a little bit before you tighten it, and it will take care of it. All right. Okay. Right back where we started. Okay. This one's about half a millimeter out of whack. So the way to correct this being skewed is there's 2 bolts underneath here and 2 bolts underneath here. You basically loosen those up, get the skew right, and then when it's set, I gotta remember what size wrench that is. The Ender 5 is a little bit better printer just because it's more stable. It doesn't have a vertical gantry per se. It's got a cube frame, so it's more stable. So yeah, if you're going to buy another printer, I would strongly suggest the Ender 5 over an Ender 3. I love my Ender 3s. I got a couple of them still, but and they work good. But the Ender 5 is better overall. Okay. '98. 97 something. Yeah, the Ender 3 or CR Tennis Pro finished some parts. Harvest it really quick. All right, it's back printing again. So that was 101. I used to go that way more. Okay, let's see what that got us. Oop. Actually moving it with my hand now. Sorry about it. Find a lower impact way to measure to that. 84, 85 even. I can tell what I'm going to have to do. So I am going to basically take up all the slack in that, tighten it, and then recheck it again because it's so loose that I can't control the movement of what I was trying to adjust. So we'll tighten that one. I'll tighten this one a little bit. Okay, so those are retightened again, so we can measure. All right, we got it less than 0.1 different side to side. Tighten that up all the way. That's tight. Check it one last time, just to make double, triple sure. We're good to go. All right, so now I need to put the Z-axis on. Hold it.
Are you done?
Huh?
Are you done yet?
No, I'm gonna grab my food here in a minute and eat it while I work. Still going. Okay. That's on. You can take the Z lead screw back out. Drop the snitch. So not to pick on Creality's assembly methods, but I can actually feel that that's a little bit out of alignment just from the get-go. So let's do the lubricant first. Get those lubed up, and then we'll do our adjustment. Okay, that should have worked that lube in there pretty good. I'm going to cheat. The last time I was fighting that Z-rod for messing with those nuts on this axis, so we're going to deal with them without the Z-rod in the way and make my life easier the next round. We got our one turn backed off there. If I didn't say anything about it before, if you get a 3D printer and you're going to do any amount of projects, invest one of those 16, around $16 to $20 kits that have like 500 M3 to M5 nuts, bolts, and other hardware. They're worth having around. Hey Dan, how you doing? We're just muddling our way through assembling 3 under 5 Pros. We're on number 2. Looks like it's taking around about an hour a piece, little less for each one, to assemble and tune the axes. There is one other tuning I'm going to do that I haven't done yet, and that will be the eccentric wheels on the carriages. That'll be the last thing I do on all of them. And switch to camps. Okay. I love these little M3 nuts with my big bear mitts. Okay. Now, there is no good way to do this double nut program that I'm aware of. Invest the money in some nylock nuts. It's way easier that way. Alright. Part of this has got to be a contortionist. Okay, so those are done that way. So now we're going to align, like we did before, this V-rod to the frame first. Find the right wrench. That's not the right one. That side is officially loose. Okay. Let's measure where the other side is at. And 17.8. That's right at 118. So I basically have a 0.2 millimeter difference top to bottom, which is better than the last one. But still probably not quite as close as we're going to want it. So we're going to double check that I didn't just measure it wrong. No, that's 117.86. Another one. May even be closer than I thought. Hold on here. So that's 117.86. This one. Get all the crap out of the way. Yeah, it's out enough that I'm going to mess with it. Okay, so okay. Now this is tighter on top, looser on the bottom. We're going to adjust it, get it where we want it, and start tightening it up again. Starting to sound like a broken record, I know, but this is the glorious life of machine assembly. It's just tedious alignment over and over again. And 117.95. And 117.95 up above and 117.85 below. So that's 0.1 millimeters, so I can live with that. Okay, so we'll go ahead and tighten it. And double check it. And it stayed there. Around 117.8. So 0.1 still, I can live with that. I don't think we're going to have any majorly out of spec parts with that little bit of deviation. We'll tighten her down. Okay, now that we got the first rail aligned to the frame, and we didn't talk about it this time, but we'd already made sure the frame was square both ways. And now we're going to do raise the thing up and down to align the other axis, the other rail. So we'll go down to the bottom, give it a quick snug. Top, give it a quick snug. Okay. I'm going to loosen the bottom again, give it one more chance to loosen or to adjust. Just in case we started from a bad place. This will get snug for its second and last time. Once I do the last one, we'll loosen this one more time. Okay, last trip up. Snug it. Anybody's watching this later and you have an Ender 5 Pro, same thing, only you got to do it twice, once on each side. So we had it aligned really well. We felt a little bit of a hitch in one of the ball bearings. These linear ball bearings have a set of bearings that run around in a circle in there. We get it just a little bit more lube. We run it a little bit more. We're not in such a big hurry we can't get this thing going exactly perfect. You want Matt to make perfect parts all the time. Hello, 3D print baking. Welcome to the stream. Not anything super exciting going on. Just assembling and fine-tuning the axes of these 3 Ender 5 Pros for Matt. Okay, so this one doesn't have near as much assembly lube on it. Just gonna wipe off. This one has a little bit more grease on it than the last one did. Well, grease is all right, but over time grease will dry and cake, and then it'll dry and cake on the lands of your lead screw, and it can actually cause slight dimensional errors. I use the PTFE lubricant because it never dries out and cakes. So. Give this one a good. Good dose. Start that lube going down it. It's sort of fun if you watch it. You can see the lube actually working it down the lands as it travels down. Right now, we're going to re-tighten this coupler up. Same deal as before. I make sure it goes down and bottoms out, and then I'm going to lift it up just a little bit so there's no possibility that it's bound up on the shaft of the stepper. I'm going to tighten it up without stripping it. Okay, so that's been done. Let's run it up here real quick. Putting the bed on. All right. Add one bed. Once we get the right screws out. We decided we were doing this over the other one. Yes, I know that it can be put over the other way if need be. I just can't remember which one gives you more Z height. And honestly, I'm not too terribly worried about it. I'm glad they put extras in. I'll have to find that later. Okay. Okay, so that's on. We are ready to move. On to printer number 3. Hey, guess what? We got to do it all over again. Use our 3D printed box cutter this time. These are called the cut tool on Thingiverse. I give them to people I use my end rolls because there's not much filament left, and I print these and buy decent razor blades for them. You can put it on your keychain, and if you get in a wreck, you can pop the airbag or you can cut your seatbelt if you're stuck in your seatbelt from the car wreck you were just in. And it's there. You'll have it right where you need it in the ignition. There we go. And this one we decided was going to be the black one. Mark its box. Here's the screws out. Is that so we can go there? Okay. Reset the timer. We're on to number 3. Oh, okay. Here we go again. I'm sorry if you guys are getting really bored, but I figured maybe somebody gets something out of this later on. At least give me some content to have until I get some other stuff recorded. If anything, it'll give people tomorrow, they can tell me everything that I did wrong when I put it together that I didn't. That'll be interesting to see how it goes. Okay. I didn't know I had anything protecting my thing, but oh yeah, have a good night. 3D print baking. Get some rest. It is almost 10 p.m. my time, and I haven't even eaten my dinner yet. Hello, Michael Cassell. We are on Ender 5 Pro number 3 on assembly. The production, lining them with my advanced assembly techniques for Matt. He happens to live in Washington and asked me if I could put these together for him and sort of pimp them out the way that mine are. Malevolent burrito. Yeah, so if you were one of my gun subscribers, I basically got told by my employer that my gun activities online weren't going to help me long-term professionally. So it's not that I can't do gun stuff or whatever, but they just would rather that I don't do that anymore. So this is my new hobby, 3D printing. And I don't know when it's going to happen, but one of these days I am going to pop in on one of the gun channel get-togethers, have sort of like a reunion with some of the guys I used to hang out with. Okay, so those are on reasonably tight. Grab the upper frame. With the bone bell. Okay. Where is that off? Oh. There we go. Amazing how things go when they're actually in the right places. Oh, nice shot. Yeah, if you're doing the assembly on these, and these ones that have the adjusters for the belt and everything don't perfectly line up for putting the bolt in, don't put it in there and cross-thread it. Just loosen it up, get it part way together. You can later on do all the tightening of the belts and stuff over again. Not worth damaging a thread by trying to force it in the first time. That happened. Home Science Ideas. Hey, how you doing? Your logo looks like somebody else's logo I'm used to seeing. Maybe I'm getting them confused. Or you're like a lot of people and have multiple accounts using the same logo. Back to that same program. Don't force it. Loosen it. All right. Okay. Got the first bolts and everything, the first screw. Okay. Okay. Same dealio. No, 11 burrito. The build size is 50 millimeters more in the z-axis. So your Ender 3 is well, the specs say 220, 220, 250, but it's actually 235, 235, 250. The Ender 5 series, the standards are 235, 235, 300. And then the Ender 5 Plus is 360, 360, 400, I think it is. Might be like 405 or something like that. It's a lot bigger, brother. But either way. A little bit extra Z height for you. This is the way the design worked out. Okay, so that lower one's square two ways. Square up here, so we can tighten that. All good there. That one squares up off of the base frame. We'll get it tightened up. Yeah, I gotta give them props. Once we got on them about square cuts on the ends of these extrusions, they got it nailed tight. Makes for a lot easier assembly. All right, now we look up here. Good. Okay, so this one is not the one that needed adjustment. We'll get that tight. That was interesting. Launch the key. Oh, my fiddle fingers leak, I guess.
Luke,
Yeah,
it's almost 10 o'clock.
yeah.
Come eat.
I'm almost done with the assembly on this one.
You said that an hour ago. You said dinner was still ready.
All right, I'll be in a minute.
You want to take your
Yeah. And you guys aren't going to get to see me put the last Z-frame and bed on tonight because my wife is not so happy that I haven't eaten the food that she so graciously made for me this evening yet. So I'm going to get this last corner tightened up, and then I'm probably going to sign off for the evening. My apologies for those that showed up late that aren't going to get to see as much, but you can catch it by replaying it and or tune in next time because there'll be other stuff to see as I do the rest of the assemblies. Get that again. Pull. All right, that looks like it's going to do it for tonight. Thanks for everybody that tuned in. Sorry it wasn't super duper exciting, but tune in tomorrow evening. I'm going to be back at it again. I will be adding all of the accessories over on the table over here. We have the orange machine, the blue machine, the black machine. So they will get those accessories. We're going to be doing the hot end fix to all of them. We're going to be doing the wiring. We have filament runout sensors to add. Bunch of fun stuff to do. And then if they get here in time, well, these came with a really nice aluminum Creality extruder. It's perfectly adequate. He's going to be putting on not this one, but an equivalent to the Bondtech BMG on here. So you get the 3-to-1 gear ratio, which gives you a little bit smoother print. And we're going to make these things set up to do some production work. I'm going to go ahead and cut these clips off before I sign off while I think about it. But anyhow, I hope you enjoyed it, what you saw. Let me know in the comments what you think. I don't get to do this all the time because I don't always have people ask me to assemble printers for them. So I thought it'd be fun to show behind the scenes of some of the work that I do that people don't always see past the help guide and stuff. So anyhow, that's what it's going to be probably the next evening, and maybe some more work on Friday midday. And if things went really badly, I'll still be working on them on Saturday. But hopefully by Saturday, it's just going to be having them running, testing, making sure everything's good. We'll have the new firmware on them and all that kind of stuff, and basically making sure they're ready to go be in a production farm. So thanks for joining me. I hope you had a good time and have a good evening.